Expansion path tells us a set of combinations of capital and labor. We have, in this case, 8 capital, 10 labor, 12 capital, 16 labor, then 14 capital, and then 16 labor. Sorry, 12 capital. This one is wrong. Okay. So there was a mistake here. I had put when k equal to 12, L equal to 16, but it should be L equal to 14 because L k plus 2 always. So when k equal to 14, L equal to 16, right? So this combination tells us there is a way to mix, right, capital and labor, which is known as expansion path, because it tells us the different combinations of capital and labor that meet the efficiency condition. Efficiency condition is MRTS equal to W by R. If you take any point here, K8, L10, K12, L14, K14, L16, all these points are efficient because they are satisfying this condition. MRTS equal to W by R, this one. So we got this expansion path with the condition MRTS equal to W by R with this one. Therefore, we say that expansion path is a set of combinations of capital and labor which shows the combinations of capital and labor that meet the efficiency conditions. If you want, you can put the efficiency expansion path as a curve like this. So this is K8 L10, K10 L12, K12 L14. So this point, and this point. So all these points tells us here, if you take MRTS equal to W by R, MRTS equal to W by R, MRTS equal to W by R, irrespective of the budget and the output level. We are not worrying about the budget, we are not worrying about the output level, but we are worrying about the efficient allocation of resources. If we are allocating our resources efficiently, then it should be something like 8 capital and 10 labor, 10 capital and 12 labor, 12 capital and 14 labor. Likewise, you can have any point here, or any point here. All these points are efficient. Therefore, we say expansion path shows us different combinations of capital and labor that shows the efficiency condition, that satisfies the efficiency condition, which is MRTS equal to W by R. If we want to expand our production in the long run, we are changing both capital and labor. Right? This is about the long run where we can change both capital and labor. Therefore, if we are planning to expand our production process, what we do, we combine capital and labor on this expansion path as we walk. This is why it is called expansion path. How, if we want to expand our production process, we should combine labor and capital with the ratio that is given with the expansion path. Then how we can get the expansion path? Already we did that. Right? So what we need to do, once we know the optimum, the condition in the optimum output level, that is MRTS equal to W by R. Therefore, what we can do, we can substitute the marginal product and the factor prices into the efficiency condition. We have, when we derive the efficiency condition, after that we can put the values of MPL and NPK and also the W and R into the efficiency condition. Then we need to solve that equation for one factor, which is given here, which is we did here. In fact, what we have done, we took MPL, MPK, and then we substitute those MPL and MPK value to this efficiency condition. Efficiency condition is MRDS equal to W by R. So MPL, MPK, that is MRDS and W and R. Once we substitute and solve it for one factor, in this case, I have solved it for L. If you like, you can do it for, it doesn't matter whether L or K. So we solve it and finally we get the expansion part. Right? So that is how we are going to get the expansion part. So as I already discussed, if a firm want to expand its production, if a firm want to expand its production process, it will be expanding along this curve, expansion path, because at any point we are getting the efficiency condition satisfied. But remember, it will never, if you look at this graph, it will never tell us what is the output level. There are different combinations of labor and capital. All these points are efficient, right? Either point E, B, C, or whatever. Is all of these points are efficient, but it does not tell us what is the optimum output level for this firm. Remember that one, right? It will be telling us what are the combinations we should have, but it never tells us this is the condition, this is the point where you are having optimum output level. If we want to get the output level, what we want to do, we need to substitute the expansion path into the original production function, right? Then if we know the output level as well as the factor prices, we can calculate what is the output level, and then at that level, what are the capital and labor we should be employing. As a firm, what we do is that, right? So we get the expansion path and solve by solving for one factor and apply that into the production function, and then we get the output level. Using that output level, we can calculate what are the capital and labor amounts. So I have given here one example. Production function is given as 2k power to 0.5 and L power to 0.5. Output level is given. In this case, output is given as 1000. W is given as 4 and R is given as 2. That is, rent is 2, wage is 4, output level is 1000 and production function is given. Now, the question is generate the expansion path and calculate the optimum K and L values. How we can do that? First, we have to get the expansion path. To get the expansion path, we need MPL and MPK, which is given, which is not given directly, but we can derive. We can derive MPL and MPK using production function. And W and R is given. So we solve that, then we get the expansion path. Take that expansion path and plug here. Let's say we got L something with K, then instead of L, you can put the K in the expansion path and solve this. Q is also known 1000. So when we solve, you will be getting what is the value of K. So I have done it here. So this is the production function. This is the output level and wage and rent. What we need, as I just mentioned, we need MPL, we need MPK. And then the efficiency condition, MPL divided by MPK equal to W by R. So MPL divided by MPK equal to W by R. If you solve this, Finally, we will be getting K equal to 2L. This is how we are going to mix. K equal to 2L. If L equal to 1, K equal to 2. L equal to 2, K equal to 4. L equal to 10, K equal to 20. Likewise, that is the given ratio that we are going to mix K and L. But it doesn't say what is the optimum level of K. With the expansion path, we cannot say. It may be 10, it may be 12, it may be 100. It depends. Right? But it says one of them, that is clear. One of them will be the optimum because you will be producing only along the expansion path. Now, as I mentioned previously, if we know output level, now we know output level, that is 1000. Then what we do, instead of K, I will be putting 2L here. Right? That is 2 multiplied by 2L power to 0.5, L power to 0.5. So we can solve this a little bit. 2 multiplied by 2 power to 0.5, and here 0.5, 0.5, it will be L. So if you solve this, finally, you will be getting L equal to 354. Right? Then we know if L equal to 354, that is here, L equal to 354, K should be equal to twice of that. That is 708. Therefore, we can conclude that to get 100 units of, 1000 units of output, to get 1000 units of output, we need to mix 354 capital and 708 labor. That is the optimum employment of capital and labor. With this capital and labor, we will be getting 1000 units of output. That is how we are going to get the optimum employment of factors in the long run. Okay, what I ask here, the production function is given. Production function is given as Q equal to K power to 0.5 and L power to 0.5. Output is given as 1000. And wage rate is 12 and rent is 24. If this is the case, first find the expansion path. What is the expansion path? Yeah, mathematically, those are the coordinating point. If you, this is regarding the question Kavishka has put, K equal to 0.5 L. Mathematically, these are the coordinating points. Like, if K equal to this much, what is the L? In this case, if it is K equal to 0.5 L, that says like if K equal to 10, L equal to 10, K will be 5. And if K equal to 20, K equal to 10, likewise, half of the value of L. So those are the coordinating points if mathematically, but economically we say this is the expansion path. How you mix, the word, technical word what we are using is the expansion path. It simply says how you are going to mix K and L. If K is 1, L is 1, how much of K? If K is 1, how much of L? That is given with the expansion path. So economically, we say this is the expansion path. Exactly as you say, mathematically, it is the coordinating points of that graph or line. So here what we need to do, first we need to get the expansion path. To get the expansion path, what we need to do, we need to get MPL and MPK. Once we get the MPL and MPK, we know that is MRTS. Efficiency condition says MRTS equal to W by R. Then what we need to do, MPL divided by MPK equal to W by R. And then solve for one factor, either K or L, whatever it is. What Kavishka has done, he has solved it for K. And then that is the expansion path. That shows how we are going to expand our production process. So we will be producing only along this curve. And then calculate K and L values right after that. Let's see how we can do that. Yes. So simply, we are having, this is our production function. K power to 0.5, L power to 0.5. If it is the case, we can get MPL. Right, 0.5, K power to 0.5, L minus 0.5. MPK 0.5K minus 0.5, L 0.5. So now we have MPL and MPK. Right? So then we can solve MRTS. MRTS equal to MPL by MPK equal to W by R. So K equal to 1 divided by 2, that's half. So if we further solve, we can say L equal to 2K, K equal to 0.5 L. Yes, Kavishka is correct. Right. So we can say L equal to 2K, or K equal to 0.5. Right. This is known as the expansion path. This tells us how we are going to mix K and L with different scenarios. If we are changing the budget line, how we are going to change the K and L. So in this case, let's say we put a table K and L. K equal to 1. If K equal to 1, L equal to 2. K equal to 2. L equal to 4. K equal to 3. L equal to 6, 4, 8. Likewise, this is how we are going to mix. Whenever we want to produce efficiently, when we have 1K, we will be mixing 2L. When we are having 4K, we are mixing 8L. So double the amount of L. And this is how we are going to expand our production process. If you want to scale up your production, this is the way. So you can easily draw that like this. So we are having here K, here L. Right. Then 1, 2, 3, 4. And here we are having 2, 4, 8, 10, 12, something like this. So then put the coordinates. So it will be something like this. Oh, sorry. It will be something like this. So this is the expansion path. This is how we are going to expand our production process this way. That is why it is called expansion path. Once we get the expansion path, now what we can do, we can substitute this expansion path into the production function. And the output is given. Output is 1000 equal to K power 0.5. Instead of L, we put 2K and solve. It is 1000 to 0.5. Then, if you solve this equation, you will be getting K equal to 707. And L will be equal to double of that. That is 1440. Right, so the answer is a bit closer to what our friend colleague said previously, but this is the answer I got. There may be, mistakes when I did my calculation. If so, you can tell me if you got a different answer. So one answer is there. So this is the final answer, right? To get 1000 unit of output, we will be mixing 707 amount of capital and 1414 labor. If you mix this amount of capital and labor, your output will be 1000. And this 1000 will be the optimum, because we are in the expansion path. That is the efficient point. Expansion path means that is the efficient point. A firm will produce only along this line because it is efficient. Right? Now, when you have a free time, calculate what is the total revenue at this point. Therefore, that I have not given the price. Ne? Yes, I have given only capital and labor. You can find the cost. You can calculate the cost, but revenue is not there. Without calculating the values, I cannot tell the price because there may be different values coming. But if you like, you can calculate the cost and determine what is the total cost of this production process. So this one, 2 power to 0.5 multiplied by K, and then we can take this to the side. 1000 divided by this one, it should be definitely, because it is 2 power to 0.5, it should be something 1.4 something. Ne? So this answer is correct. For all, the answer is correct. There is no wrong. K equal to 707, then it should be equal to 1414. This answer is correct. The question what Avishka is having this one. We say K equal to L here. If so, we should have the other way around. Here, L equal to 2K. Now, both are correct. Right? This is K equal to L with this. Remember, this is a different production function, which is efficiency parameter 2 is there. And W equal to 4 and R equal to, given these functions, we are getting this, right? If you want, you can write this as L equal to 0.5. Right? This is the expansion path given this information. And this is the expansion path, L equal to 2K, given this information. There is no efficiency parameter here. And look at the factor prices, 12 and 24. This is why we have this relationship. So don't take this one, and this one should be the same, right? So if you graph them, this is the expansion path for the first one. If you put the same scale, expansion path for the second one, something like this. And maybe this is firm 1, this is firm 2. These are two firms because you see different production functions, different factor prices. So depending on that, we have the expansion path. So these are two calculations with two separate information. This exercise also shows us that there is a expansion path which is L equal to 2K. When we mix 1L, we need to mix 1K, we need to mix 2L, 2K with the L. Simply, if K equal to 1, we need 2L. And if K equal to 2, we need 4L. Likewise, we combine labor and capital, which is along the expansion path. Then, as we previously discussed, so the output is given. If our output level is 1000, then what amount of capital and labor? To get 1000 units of output, we need 707 capital and 1514 labor. Then we will be getting 1000 output.